All right, let's get into it. Today, we're going to build a notification system, right, from scratch. But hold on. Before you start thinking about APIs and message queues, we have to talk about what a notification system actually is. Because honestly, most engineers get the whole point wrong right from the very beginning. And this right here, this idea changes absolutely everything. We're not just building pipes to shoot data from one place to another as fast as we can. No, we are managing something incredibly scarce and valuable, a person's attention. Success isn't about speed. It's about making sure the interruption is actually worthwhile. If you mess this up, you'll build a system that people will literally go out of their way to shut down. So that's the big question, isn't it? If we're not just trying to be the fastest, then what are we even optimizing for? Getting this right is the absolute key to designing a system that users actually value instead of just finding, well, annoying. So stick with me because we're about to build that exact system, one piece at a time. So here's the game plan. We're going to start with two principles that are completely non-negotiable. Then we'll use those to put together our architecture, block by block. After that, we're going to throw some real-world chaos at it and see if it breaks. And all of that will lead us to the one true goal every engineer working on a system like this should have burned into their brain. Okay, our first principle, asynchronous fanout. This is a must. All it really means is that the part of your app that creates an event, like a new comment or a sale starting, cannot be the same part that actually delivers the notification. They have to be separate, totally decoupled. Let's dig into why that's so important. Let's just make sure we're on the same page with this term fan out. Think of it like this. One thing happens and you need to tell potentially millions of people about it through push notifications, emails, you name it. But the most important part of that definition, without blocking the producer. Your core app function, like processing a payment, should never have to wait for a notification to send. Trying to send notifications synchronously is just asking for trouble. Why? Because the real world is messy. People's phones are turned off. Apple and Google have really strict limits on how many pushes you can send. And when a delivery fails, which it will, you have to try again. If your main services had to deal with all that, your whole application would grind to a halt. You don't want your entire payment system to fail just because one user's phone is in airplane mode. So how do we actually do this fan-out? Well, it's a classic engineering trade-off. On one hand, you've got fan-out on write. That's like pre-calculating every single delivery job the second an event happens. It feels super fast for a small audience, but for millions of users, your system would just explode. On the other hand, there's fan-out on read. This is cheaper up front, but it can feel slower to the user. The truth is, most big systems end up using some kind of hybrid approach. So here's the bottom line for this section. If you ignore this principle, a small slowdown from, say, Apple's push service can cascade backward through your entire system and take down your most critical services. Decoupling isn't just a nice idea, it's a survival tactic at scale. All right, on to our second principle. We've solved the machine problem, now we have to solve the human one. Because the real bottleneck in a notification system isn't your server CPU, it's a person's patience. Let me be crystal clear about this. When a user says, "Don't bother me after 10 p.m. or only send me critical stuff," that is a hard rule. It's a non-negotiable contract you have with that person. It is not, and I repeat, not a friendly suggestion. And the consequences for breaking that contract? They're huge. You don't just annoy someone, you completely destroy their trust in your product. On top of that, platforms like Apple and Google will actually penalize your app for being spammy. And what's the worst case scenario? A user gets so fed up they just hit that uninstall button. The stakes are really, really high here. This brings us to rate limiting, but with a really important twist. See, most engineers think of rate limits as a way to protect their servers from getting overloaded, but in a notification system, you're doing the exact opposite. You're protecting the human from being overloaded by your system. So our rate limiter basically has to become an empathy engine. It needs to understand things like attention fatigue. If someone gets 10 likes on their photo, do they really want 10 separate dings from their phone? Or just one nice summary? It also has to respect those hard limits from Apple and Google. And above all else, it has to protect that user's trust, that we won't abuse the privilege of being on their lock screen. Okay, so we have our two big ideas, asynchronous fan-out and human-centric rules. Now let's stop talking theory and start translating this into a real system. Let's see what components we actually need to build. So here's the journey. It starts with an event producer, maybe your checkout service. That event hits our ingest service. Next, we figure out the audience. Who needs to get this? Then, and this is the crucial part, we run it through the preference filter.
Only after all that does the fan-out engine start creating the individual messages that get sent off to the gateways.
And here's the whole shebang. Look at how the business services up top are totally separate from the delivery channels down at the bottom. All the smarts are right there in the middle, in that notification distribution block. That's the brain of our operation. It's where we handle the scheduling, the templating, and most importantly, where we enforce all those user preference rules we just talked about. So a design on a whiteboard always looks perfect, right? But the real test is what happens when things go wrong. So let's throw some common high-scale disasters at our architecture and see if it holds up. First up, the thundering herd. What happens when you need to send a notification to 10 million people all at once? A simple approach would try to create 10 million database entries instantly, and boom, your system is toast. But our asynchronous design saves the day. We use queues to create a steady, manageable flow of work instead of a giant spike. We can use smart tricks like lazy fan-out to figure out who to notify in smaller chunks, avoiding that initial system-crushing explosion. Okay, next scenario. Apple's push notification service suddenly goes down. What now? Well, because we're using queues, our delivery workers will just try, fail, and then back off to retry a little later. The queue will start to fill up, acting like a giant shock absorber. This keeps the failure contained. It doesn't cascade and take down our whole app. We can even get smart and start dropping low-priority notifications to make sure the really important stuff gets through when things are back online. And finally, the one we all dread, the notification storm. Some bug causes your app to send the same person 50 notifications in 30 seconds. We've all been there, right? This is where our human-centric rules become our heroes. Those per-user rate limits act like a circuit breaker. We can also do clever things like collapsing similar alerts into one. You have to remember, in this kind of system, deciding not to send a notification is a core feature, not a bug. All right, we're almost at the end, and I want to leave you with what I think is the most important mental shift you can make. It's a trap that so many smart, experienced engineers fall into when they think about notification systems. The trap is thinking that your job is to guarantee that every single notification gets delivered no matter what it takes. It sounds right, doesn't it? It sounds like you're doing a good job, but it's fundamentally the wrong goal, and it will lead you to build a system that just spams users and ruins their experience. Here's the correct way to think about it. Your goal is not 100% delivery. Your goal is relevance. It's about preserving the user's trust and their attention. You have to burn this into your mind. A dropped, unimportant notification is infinitely cheaper than a frustrated user who uninstalls your app and never comes back. And that really brings us to the core takeaway of this entire explainer. The most sophisticated logic, the most valuable feature, the truly hardest part of building a great notification system isn't about sending messages. It's about having the intelligence, the discipline, and the empathy for your users to decide when the right thing to do is to not send anything at all.